Welcome to our TCU MODAG webinar with the MPCA, who are going to talk to us today about continuous monitoring and continuous real-time load calculations. For those of you who may not know, TCU MODAG is the Twin Cities Water Monitoring and Data Assessment Group. It's a group facilitated by myself and Jen Kostrowski at the Met Council, but we have a steering team of a variety of local and regional folks who help us plan events. So the group itself is mostly Twin Cities professionals, although we're open state-wide and to other states as well. We try and get together semi-regularly to share monitoring, assessment, and data storage information and share best practices and ideas. Throughout the pandemic, we've been hosting webinars just like this one, and we hope to continue doing them even as the pandemic ends, because they've been successful and it's a way to get a lot of people together with a fairly small time investment. So we were able to have our first in-person meetings event since 2020 back in September at Keller Regional Park, which was a great networking and information sharing event, and we're planning to have at least one in-person meeting again this year. It will probably again be outside just to manage risk and ensure every participant is comfortable. So keep an eye out for an email sometime this spring or summer for details on what we're planning. If you're not on our email list, I will drop a link to that in the chat in a few minutes. We do try not to spam your inbox, but that's the way to hear about our next events. So like I said, we've been doing these webinars on and off throughout the pandemic. And at this point, we have a nice stable of them on a variety of different topics that we've all recorded. So I will also drop a link in the chat to the website where the links are all stored. So you can go and catch up on previous webinars. We've had ones on the state stormwater manual, on biological assessments of lakes. There's one on art and water, so they've been a wide variety. And we're recording this webinar as well. So if you have a coworker who wasn't able to attend, you can direct them to this recording after the presentation. We do ask that you keep your microphone and camera off during the presentation, since we have a fairly large group. Feel free to post questions to the chat during the presentation. We won't probably be stopping and pausing to answer them as we go, since we have multiple presenters, but we will make sure they get asked. And then at the end of the presentation during question and answer time, you can also feel free to raise your hand and you can come and ask your question directly. So getting to the reason we're here, we have a great group of MPCA water monitoring staff with us today: Mike Wallerach, Jen Ender, and Eileen Campbell. This session's a little bit longer than our usual 1 hour because they have so much great information to share with you on water quality, continuous water quality monitoring, and real-time load calculations. So with that, I'm going to pass it off to Mike to begin the presentation.
Okay. Hi, everyone. I'm Mike Wallerich with the Pollution Control Agency, and myself and Jen Ender, we work out of the Rochester office, and we've been sort of dabbling in continuous nitrate probes for, well, Jen's been doing it longer than I have, but recently we just started trying to produce real-time loads, and our goal is to get them out on the web basically in real time. Thanks to Eileen in our Mankato office. She's kind of the behind the scenes whiskey database person. So between the three of us, we can usually get it done, and we get a little bit of help from our IT also. So Wade Gillingham, who actually is out of the Marshall office. So Jen is in the watershed division, which primarily is out of Southeast Minnesota. She does a lot of the nitrate stuff on springs and down in the karst portion of the state. Eileen and I, we work in the Watershed Pollutant Load Monitoring Network and continuous data. I can never get it exactly right, but the continuous data is what this particular project falls into. So with that, we'll get going. Maybe. There we go. So why do we use the continuous probes? Most of you guys have a pretty good field experience and some background. So, I mean, this kind of goes without saying, but, you can take a picture of something. You can take an X-ray of something. You can do an MRI of something, or you can do a CT scan. So This continuous data is somewhere between a MRI and a CT scan. It gives us pretty high level of detail without too much detail. 15-minute time series data is primarily what we target. Sometimes we can convert it into daily uh, loads, between daily flows and daily loads. So what this does is it gives us more accurate daily loads, and I'll go in to a little bit of detail on how accurate some of these loads really can be, and basically how well we're doing uh, with just the traditional way of calculating loads. So, I mean, all in all, this basically gives us higher detail, better quality with less work, allegedly. Um, there's always with any field work and any sort of monitoring equipment, there always is its shortfalls. So what are we doing with this continuous data? Well, we produce nutrient loads. Sometimes people will use these probes if there's a downstream drinking water source that's drawn from a surface water source. They can use this data to identify or to tell them whether they should be using wells, or they can pull from groundwater or surface water or groundwater sources, depending on nitrate concentrations, and they can get them in basically real time when everything's working properly. Uh, the water quality standards are coming, like we all have. I mean, we all know about IDIs and stuff, and uh, chronic and acute water quality, or what thresholds for certain invertebrates and fish and whatnot. Um, so it can be tied into some stressor ID stuff, and what we find is our local partners really like it for addressing nutrient management, at least in our ag areas. Where does this uh, style of monitoring excel? We like it in areas with really flashy hydrographs. One place we have this is located in the Cedar River down near Austin. We've got a pretty heavy urban runoff effect that happens in there, which is really tough to monitor. So we've got our probes out there, and we can catch that data when we're not necessarily there. Um, we can do this upstream or downstream of wastewater treatment plants to see exactly when people are discharging and not. So Jen uses this all the time down in the karst area for nitrates to see what's coming through the groundwater. Um, Subsurface drain tile, drain ditches and whatnot. We can see exactly when these drain tiles are pumping out the nitrates. So it comes in pretty handy. Um, so the seasonal comparisons that I'm going to kind of talk about. First, I'm going to talk about calculating loads in a traditional sense. We use Flux 32. We take roughly 25, and in this example, almost 50 samples in a season to calculate our loads. Well, the and we find we do pretty good. We're right around, if you can see on the screen here, we're right around that 4 million kilograms a year, on average, give or take. So our seasonal load, we are doing pretty well. Our flow weighted means are fairly close. Oh, it's back. With our Nitrate data, we're kind of right in the middle of that 3.8 to 4 million. We're at 3.9 million kilograms a year. So the Nitrate, I mean, we're right in there. So there's nothing wrong with the way that we traditionally calculate loads. It's just we get a little higher detail in this, and this is for the annual loads. So where this excels is when we're looking at daily stuff. So this is a little tough to see, but this is basically a full year's worth of loads. The green line is where I ran the loads using 48 samples in a year. The kind of the maroonish line, reddish line is where I use 25 samples in a year. And the purple line is our continuous loads that were calculated via Nitrate data. So I'm going to dive in. I mean, this is confusing now, but I just want you to see how it is. And I mean, just notice the difference in the lines compared to that purple line is the one that we're really looking at. So we're going to dive into this a little bit closer and look at just this portion of the page graph. So yeah, I mean, it should be no surprise. I mean, we can see, I mean, we do make a few overestimations. I mean, the more samples we collect in a year, generally, the better calculation we get on a daily scale. But with this Nitrate, I mean, we see some little dips and some peaks that we were kind of missing before, but generally speaking, we follow close to the same trend line. It's just what level of detail are you interested in? What else can we use these continuous probes for? We can use them as surrogates to other forms of nitrogen. In the last couple of years, we've dabbled in with turbidity probes and converting that to TSS using primarily linear regression. We apply a linear regression to it, and we think we've got it pretty close. One thing to note when we do that is it's very site specific. Generally, each watershed contains the same types of particles, so particle size, particle sources. This isn't that that relationship from one watershed to another is generally not there with TSS and turbidity. We've tried, there is a setting on the Nitrate that we use, or I'm sorry, the Solitax for turbidity, or for TSS, I'm sorry, but it was just, we could never get it fine-tuned enough and accurate kind of across the board. You need a lot of samples and it takes a lot of calibration. So it wasn't quite, we just couldn't get it to work as well as we could get the turbidity to TSS regression to work. So this data gets used in the RAPs and also in the stressor ID programs. So with that, I'll give it to Jen. That's kind of the gist of what we do with our data and why we are collecting the data. And Jen's going to talk about how we collect the data. She's kind of the expert and one of the first ones in the agency that started using these Nitrate. So take it away, Jen.
All right, so I'm going to cover the different sensors that we have been using. This first one here is the Nitrate that Hawk sells. And there are multiple sensors you can choose from depending on your applications. And we went with the Nitrate Plus SC, which is the second column here. And there's also different measuring paths you can choose from. And we went with the 2 millimeter, which ranges from a 0.1 to 50 milligrams per liter. And the sensor weighs about 8 pounds and just over 13 inches in length. And the sensor contains a 2-beam UV light that also compensates for turbidity. And the measuring window is mechanically cleaned using a wiper, and the wiper is protected, which I'll have a picture later on kind of showing the wiper situation on the Nitrate. The controller here in the upper left is the SC200 that we have been using, and they are actually discontinuing, and they are coming out with the digital SC4500, which is the upper right picture here. It's touch screen, so it's kind of finicky, but. And then one nice thing with these controllers, you can also see the real-time nitrate value when you're there. And then I was actually looking at the Hawk website yesterday, and I see they're going to be discontinuing this Nitrate that we're using. And they're coming out with the NT3 series. And apparently it has the power to do both nitrate and nitrite in one. And it actually appears to be cheaper as well. And I'll cover costs later on. This sensor is actually made in Germany. And kind of a fun fact that they're actually meant for wastewater treatment plants. But the Nitrate is a energy hog. So your best bet would be to plug them in if you're able to, if you have an outlet nearby. Then also, a lot of our sites are more remote. So we have 2 deep cycle batteries connected in series and that are connected to 2 100-watt solar panels and able to run these sensors. But we're finding that this sensor is pretty robust and accurate. And anything under 1 milligram per liter with really turbid conditions, we're seeing that the accuracy is not as good. But with, like, Mike takes 50 some samples a year at his site, so we're comparing it with the continuous data that we're getting, and we're actually seeing like 0.3 milligrams per liter or less of a difference. So we're quite impressed with them. So here is the Eco-N, and then they're also called Nicos, depending on what company that you purchase them from. So it's a continuous optical probe that has a 2-beam UV absorption. And there's 4 different path lengths you can choose from, depending on your nitrate concentrations and turbidity conditions. And we went with a 2 millimeter path length, which ranges from a 0.25 to 30 milligrams per liter. And this sensor is actually longer than the Nitrate. It's around 18.5 inches long and smaller in diameter. And you can see in the upper picture here, the black unit, that's the wiper unit. So it's on the outside of the actual sensor itself. So you can see that it's exposed and more vulnerable to any kind of debris or anything that may come along. And our watershed unit's actively partnering with MDA to support their monitoring efforts and the Root River Field to Stream Partnership. And also Fillmore SWCD is helping out with the project. Mike and I actually went and helped deploy these sensors, and we tried to put them in a plastic tubing type situation where you got holes in it to let the water run through in hopes that we can protect the wiper. But we've already had an issue with one of the wipers malfunctioning. So I personally do not have hands-on experience with them after being deployed. SWCD is early, but I have gotten notes from MDA saying that they're seeing 1 milligram per liter difference between lab samples and what the actual sensor is reading. Keeps moving on me. All right. So one thing to note with talking with Hydromet, their sales rep, he had told me that if you're wanting to deploy a nitrate sensor in high turbidity, that your best bet would be to go with a Nitrate. And then YSI came out with a nitrate probe that you could put into their sonde. It's called a Nitrate UV nitrate sensor. And along with this, you're going to need a turbidity sensor because the nitrate probe reads off of the turbidity probe. But it's a LED light source that delivers UV energy at 2 different wavelengths that picks up the presence of the nitrate and then some types of natural organic matter. The kind of downfall of this probe is the measuring range is only 0 to 10 milligrams per liter. And for power wise, of course, the sonde takes D batteries. So as a power source, it's not that big of a deal. And we've only actually, as a watershed unit, had deployed it once. And looking at the data looks pretty good, but it follows the turbidity data. So if there's a spike in turbidity, then you get a spike in your nitrate. But we're in hopes to deploy the XO sonde more this coming field season, and in hopes to actually deploy it with a Nitratax to compare the data. But of course, in Southeast Minnesota, we kind of have issues with higher nitrates, so we'll have to find a site where it's 10 milligrams per liter or less. All right, so the costs. With the Nitratax we had ordered back in 2017, the Nitratax was $17,000 and the controller was $2,000. But last year we ordered another Nitratax sensor and controller, and of course everything is coming with a surcharge now. So the sensor is now $24,000 and the controller is $3,000. And the EcoN comes as a bundle, so you get your sensor, your SDI 12 converter, the wiper, and 5 wiper blades with it for $8,900. And then your Nitrate with YSI, the probe is around $6 to $8 grand, and that's pretty decent. But if you don't have the sonde, then of course you got the cost of that and the handheld, and then you also of course need the turbidity probe and temperature probe. An additional cost that we have, we actually, with Hawk, we came up with a field service partnership where 2 times a year they come to our site, and the first visit is usually like a cleaning and a calibration, and then the second visit they're actually taking the whole unit apart. They're changing O-rings, desiccant, changing the wiper. They're making sure firmware is all up to date. And then also, if throughout that year we have any issues or problems where maybe I need to send it in to bench services, which is in Ames, Iowa, which is really nice, pretty slick. We get it there and back within a week usually. Yeah, any problems, they'll send a tech guy right to the site and try to figure out the problem. And then to continue on with the maintenance and calibration, Mike and I actually go to the sites once a month and we do a side-by-side calibration check and also a really good cleaning and make sure everything's running properly. You can see in the picture here on the right, there's a lot of fine sediment that got into one of my Nitratax sensors. So we'll just take them apart and make sure the wiper's good, and we'll clean all that sediment out. And like I said, that we can send the sensors in to Ames, Iowa for Hawk, but with the actual EcoN sensor, they're also made in Germany. But I think there's a tech station we can call in Texas that helps out. Otherwise, every 2 years for the EcoNs, I'll have to send them to Germany to have them cleaned and maintenance and calibration. Few issues that we've had with the sensors over the years. I run into problems with some of my spring sites where there's not enough water to actually cover the sensor. Then, of course, the fine sediment, like I mentioned. We had battery issues in the beginning, but we have all that figured out now on how connected as series and with the solar panels. We had a little critter chewing on one of our cables. So we had that sent in and fixed. And then Mike finally talked his supervisor into a Nitrate, had it installed maybe a week, if 2 weeks, and got hit by lightning. So Mike had to go back to the supervisor and ask for more money to have it repaired. So pretty much the right instrument differs by site and situation. And they kind of both have their strengths and weaknesses. It's not moving. There we go. All right, so here's some pictures of our site installs that Mike and I have. The two pictures on the left are at the Cedar River. We have it set up on a sled system where we can slide both. We have both the Nitrate and Solitax mounted to it. And of course, we can bring it up and down, and it helps get away from the stream bank. And then we have it set up behind that bridge pillar so that hopefully large debris doesn't hit it. And then you can see here we have our Nitrate and Solitax hanging from the bridge to do our side-by-side calibration. And on the right over here with the white PVC, we put our sensor inside there, and then that goes into our big black PVC pipe here that Mike is working on. And we lower that over the bridge, and they both dangle into the Zumbro River there in Kellogg. So anything you want to add to that there, Mike?
No, I think you've covered it pretty well. Yeah, you kind of got to be creative every time. When you do a site installation, you want it in, obvious, good moving flow, and with the cost of these sensors, you want them protected as well. So at the Kellogg site, we've got a series of chains and heavy cables attached to the PVC, and we've got them protected as much. So if a big tree or something were to float through, hopefully these sensors would essentially just bounce right over the top of them. The only issue we really have with this style of mounting system is we need to watch the water levels and adjust the chains and cables accordingly. You obviously don't want it dangling out of the water or, parallel with the surface of the water. Fortunately, Jen lives right near the site, so she can kind of keep an eye on it. I think she drives by it at least once a day or every couple of days. So that's all I have.
Yeah, sometimes too, we gotta watch that we don't get it too close to the stream bottom, which has happened. Okay.
Okay, so I'm going to take over and talk just a little bit about where we store all of this data. 1, 2, 4. Oh, I didn't. Okay. So we have a WSGI database, so Water Information Systems, KISTers, that I know some of you out there have as well. We have this database with Department of Ag and Department of Natural Resources. We work together. We have interagency policy groups that talk about all this stuff, and we make sure we're doing things very similarly or the same between the different agencies. So this is just a screen grab from our water quality policy in terms of what we do kind of overall for any type of continuous water quality policy. And it's just that, we currently don't estimate any data. We're knocking out the data that is bad. We want to make sure that we check it with a secondary sensor. If it doesn't happen, then we're going to code it unknown because we don't know what's going on with that sensor during the year. And then we also make sure that we are checking against our NIST certified or NIST traceable thermometer. with all of our equipment, and then follow our field SOPs. So that's slightly different depending on the program and the project. So Tiffany Shells and Jen and I, mostly Tiffany and Jen, came up with some kind of thresholds for qualities of our data in whiskey. This is based a little bit on what USGS does, and basically we're comparing those lab data, that the samples that Jen and Mike are collecting at the station, to what the sensor is actually giving us, and then determining whether we need to downgrade that data, make adjustments, etc. If they are really low, and especially in high turbidity systems, we do have some wiggle room for professional judgment to see if correction should happen, or if we should just, not correct at all, or even delete those data. So in terms of moving into load calculations, so we worked with Noah at Kisters, and we got a few options to be able to calculate loads within whiskey. One of them is there's an actual load calculation agent. You can use a general correction agent for it. You can use chi-script as an agent, or there's a chi-script report option. He sent us all of that in a PowerPoint. Working with Wade Gillingham, our system administrator, we decided that the best course of action for us was chi-script. This didn't work right out of the box, obviously, for our system, because everybody's a little bit differently, but it did give us something to go off of. So this is what we ultimately ended up with. I'm sure a few of you maybe can understand what's going on here. It's okay if you don't. I just wanted to put it in there and, for a couple of people, if you were interested in seeing kind of what it looks like, and we can definitely provide that for you if you are interested. So he modified it to make it work for our system and the units that we're using for flow and concentration. Just a little bit about how we have things set up within whiskey. So we have our station, and then we've got all of our parameters, and this has a lot of them. This happens to be a USGS station. We do scrape all of the USGS flow data at stations we're interested in and bring that into whiskey. It really helps us with load calculations, streamlines things for some watershed comparisons, being able to visualize some of the data. So it works really well for us. That happens on a very regular basis, that we have that set up coming into the system via telemetry, essentially. And then we've got the nitrate plus nitrite, which isn't completely accurate because it's just nitrate, but this is where it ended up going. And so then we calculate a mass off of that. Also, this is in our dev system right now. We haven't moved it to production, so we can tweak things a little bit sort of as we move forward. And then we utilize those two to actually calculate the mass or the load. And then we also aggregate it to a daily total time series. So we have our 15-minute time series based on the telemetry of the flow and the nitrate sensor, and then aggregate that up. Okay, so this is what the unit value data looks like in whiskey. So you saw it on Mike's screen a little bit. He was kind of zoomed into 1 year, but you can see all those little ups and downs. This is the raw data. This is what would be going out onto our website, hopefully eventually. Well, it will make it happen, but it's going to take a little bit. All of our data are served up on the cooperative stream gauging website currently, which is run by DNR. And so there's different agreements that have to happen there between like the people that we work with at DNR plus their minute. And so I think we'll get it there, but it's going to be a little bit. So this is going to be, you know, these are loads. This is real time. This is anytime there is a sensor value and a flow value from telemetry, we'll be able to produce and provide a daily load or even a 15-minute load for that point. Might kind of show this a little bit already, but I wanted to show you what it looks like within Whiskey. So the calculated mass from the sensor is kind of these red bars here. The blue line is what we have pulled in from Flux. And so you can see, like he showed, that it does, you know, pretty good. This is also the daily data. It does pretty good most of the time. There's definitely times where it's different. Some of this is going to be depending on, you know, like this event, you know, Mike got a sample like right here. And so when we're utilizing that in Flux, we're adjusting, you know, and we're not necessarily adjusting the Nitrate data to that. It's higher than the Nitrate load calculation. And then other times where, you know, there's maybe less sampling later in the year, you'll see a difference between those as well. So that's basically just what, you know, it looks like in the system, what our plans are. The daily data is also going to be available for public consumption as well. And then we do have a couple of issues. So right now we have it just in our Whiskey development system, and we are working with Kisters to try to figure out what the heck is going on. So our first issue is it looks like there's no data. When you go in to look at the time series, it's completely blank, but when you graph it, it's there. So we're not sure what's going on there. Another issue is that for some reason, even when there is no nitrate data, so this is the sensor data, this is the discharge data, this is the calculated load. So somehow Whiskey is deciding to calculate these loads somehow. So we need to probably tweak our Chi script. We're still waiting on Kisters to get back to us about that. Moving forward, like I said, once we hear back from Kisters, we'll get everything working. We'll move everything over to production. Once it's there, it will be available via our web services or even requesting it from any of us. And then we will work to get data served up on that CSG website, which updates every 4 hours. And so once that happens, then it also will be available there. That is all I have.
I just had I had a couple things to add about, you know, Jen made reference and I made reference to it of, you know, collecting 50 samples per year at each site, which is a lot. Now that isn't our standard practice. Generally our standard practice for load calculations is 20 to 30 samples a year, hopefully more so around 25. We just collected almost double the amount of samples because we were out there doing calibration checks and whatnot, and we wanted to see how accurate these things really were. And it was a way to test how accurate our traditional sampling method is of only collecting 25 sites. So that's those different levels of resolution, in case that was a little unclear. But no, we aren't deploying one of these Nitrate and collecting 50 samples on a regular basis. That was kind of in the experimental trial phase of it. And but no, thanks for giving that presentation. I lean on, you know, sort of the black magic that happens behind the scenes, because I don't see that. I just ask for things to happen. In my mind, it should happen a lot easier than what it appears.
And no matter what, we're always going to be collecting samples alongside these sensors. We need to be checking them against what's happening in the lab to be able to tell whether there's fouling that's happening or an error in the sensor. So some sampling has to occur. Kind of exactly how many samples that is moving forward. When it's not at one of our load stations, we can, we'll have to do some work to decide what that looks like best.
And I can just say another to add on, Jen was talked about some issues that we had, and something that I had forgot to mention, but getting this data to flow through telemetry, since DNR and USGS generally collects the flows, we have to work with them to get this data in the proper formats and get it sent through telemetry according to their standards also. So there's a lot of moving parts to this, and that's just a sort of an agency or government issue that we are working through. Now, it's also, if you don't care about real-time loads and you just want to collect the data, you can also store the data in the SC200 controller itself and download the SD card, or take the SD data off the SD cards at whatever interval you want. So, I mean, if you don't, and then you can manually calculate the loads, and we have spreadsheets to do that after the season. So yeah, you don't have to just send this data straight through telemetry and calculate real-time loads. You can do it after the fact, and that's kind of what we were doing in the past. So,
and what we didn't have in the past is the ability to calculate the loads within whiskey. So now we don't have to worry about the spreadsheet unless people want to use it, but they can just dump the data into whiskey and the load will be magically calculated. And our practice is, even with telemetry stations, we still download the data and load that as well. So we've got a telemetry time series and a raw logger data time series that get merged together, just to make sure if there's any gaps in telemetry, we still have all of the data that's there. And we could do our own telemetry, but we really want to work closely with our partners at these stations and try to leverage what they already have there for equipment, so that we don't have to duplicate at all of these places. We don't want to go see like 5 different agency boxes all on the same bridge, collecting slightly different data that could all be collected together. I don't think that's a good look for any of us. But
So are you guys ready to take some questions?
Yeah.
Okay. Well, I could start off, and then I see we have one question in the chat, but folks should feel free to raise their hands and ask in the chat. But as a starter, what is your long-term plan for these real-time load calculations as compared to your historic flux load calculations? I'm concerned about the gaps that will inevitably happen due to equipment, due to weather, and then you'll have a gap that seems really hard to fill. So what is your thought? What's your plan going forward?
well, I mean, I can take the first stab at it. It kind of depends on what the purpose is. I mean, you need to have a purpose at that site. If you want 15-minute loads and you are on a stream that you're trying to that you're studying for protection, or some reason where 15-minute loads are important, then we will obviously make that a higher priority to keep that running. And with it being online, if it goes down, we can shoot out there, and that's if we're monitoring in a sensitive area. Maybe it could be drinking water where it's public health. I'd say that's a pretty high priority. Otherwise, if they do go down, then I mean, I'd say you'd have to default to using a different water source for drinking water. So
yeah, and I think I would echo what Mike said. It depends on the purpose of the project and monitoring. I don't foresee us going away from what we're doing for the WPLMN stations. I think that will probably stay similar, at least for a while into the future. Changing methods has a has an effect on how our trends get run, and all of that. So we don't want to deviate too much to be able to keep that data set continuously working for what we need it to do. But in terms of other places, we might do it slightly differently. If we're just looking for, general estimates of what the nitrate is in real time, like, that's going to be different than needing it for a permit or something.
Yeah, and if we do have places, like maybe outreach, maybe there's some land use that's going on that we know is having a pretty significant impact, maybe publishing those loads on at certain times or certain key times can be a good outreach tool and can be used by local partners to try to find some best management practices to try to curb that.
Got it. That's really helpful. Jen, do you want to go next?
Yeah, and I apologize if you said this. I had to go a little bit. I had to go take care of something in the middle of this, so apologies if you should say this. For water quality standards or just looking at the water quality assessments, is this continuous sensor data applicable, or does it still have to be the grab samples to go into those sort of assessments?
It hasn't been used yet for assessments. And so generally what that has to do is kind of go through our assessment group and decide, well, how they want to handle it. Like, for instance, dissolved oxygen is often more of a supporting measurement to actual instantaneous samples, rather than utilizing it directly for assessments. I think that probably could change a little bit over time, but right now we aren't using it for assessment work. We also don't have a standard for nitrate in most cases on most streams, and it sounds like that probably isn't going to happen in the near future. So on drinking water, secondary drinking water streams, I could definitely see using it for that. And then they're also utilizing our daily concentration data from flux to be able to look at nitrates a little bit too in assessments. That's getting pulled into our assessment machinery for supporting data.
Cool, thank you.
Welcome.
Gonna encourage folks to put questions, it could apply to your program or be about the computer side of it or the equipment. Feel free to put them in the chat. So Sarah Wine had a question. Great info. Does the test of collecting samples in conjunction with in situ measurements, like Mike just talked about, justify any of your decisions either way? As in, does it justify current methods of taking a certain number of samples per year or spending quite a bit of money to have the in situ sensor? Since those initial values Mike showed were very similar, especially since you can use whiskey to get real-time loads with collected sample concentrations. I think you touched on that a little with my question, but I think there's some good additional questions in there. Can you guys read that?
Don't know where to look.
It's under the chat. If you click on the chat button, because the top.
Well, Mike's looking for that. I can talk a little bit about the whiskey real-time stuff. So that's collected with that in situ sampler is where we're looking at the real-time loads for whiskey. Everything else is going to be delayed a couple of years because we're waiting for, all of our WPLMN stuff is waiting for final flows from USGS and DNR. And so those are delayed probably 2 years from when we collect the data. So we're just working on 2020 loads right now. So this really would be a way to get the information out a little bit sooner, more in real time. So at least for those stations, we're still going to collect a lot of samples and we're still going to run flux, but Mike can talk a little bit more about, or Jen can talk about what that might look like on other types of stations.
Yeah, I think it's just important to know, the real-time aspect of this, and what resolution you're looking for. I mean, if just the daily flow is enough, or a daily concentration is enough, and an estimate is enough, you know, give or take 10-20%, then you know, that the way to go is the flux calculations. If you're looking at, you know, thresholds that maybe insects can live in or not in, you know, if you have some sensitive species, then the Nitrate data and the real-time 15-minute data might be more applicable. So it all depends on your goals, you know, and if you want loads right away and you want, you know, you've got your real eager people, you've got BMPs ready to go in and you want to get after it right now, the real-time stuff can see if you want to see immediate results or try to see immediate results, then the continuous data is the way to go.
Great, thank you. I really like that focus on starting with your goals. Tyler, I see you have a question. If you want to jump on and ask it.
Yeah, I was curious if you have a strong recommendation on deploying from the bridge or using the rail systems, the bank mounted systems. If you have if one has is a like strong preference, one or the other.
I actually like the sled better. The dangling from the bridge, they're heavy. I don't know about you, Mike, but I'd rather do the sled.
I like the sled for ease of use, and you're not doing a lot of the work on top of the bridge on alongside a busy highway. I like the option of being able to get the probe right in the bow leg of the stream and out in the flow a little better. Jen and I visited USGS down at a stream down at the Turkey River down in Iowa as part of their continuous nitrate network, and they kind of do the same thing. Whatever happens to work best at the site. That sled system, we just happen to have that bridge piling there we could use for protection. We had deep enough water. It works. We do see a little bit of a difference in the cross section because there's a wastewater treatment plant upstream. It's never been more than the 5%, but that is what our threshold is. So it's real site specific, and you just kind of have to do with what gives you the best data and what's actually going to work.
Did you say where you got the sled? Like if I was gonna find, do you just find it in a warehouse, or is there a place you can order those?
We are borrowing it currently from USGS.
You stole it. Okay.
Well, they just they're letting us use it until they need it. So yeah, no, we were partnered with them at that site. They provided the sled, and then when USGS quit partnering with us, they said we could keep the sled until they need it, and we've had it for 3 years now, and they never asked for it back. So they know where it's at. They know we're using it.
All right. Well, I think I'll put a link to all the USGS sites in Minnesota in the chat for people to go get their own then.
Yeah.
Thanks.
I'll step on. This is, sorry, Will Lund. I work with the USGS. I actually installed some of these sites, and that is my sled. But I can share where we got it from, if you're interested, Tyler. And a note about the install: the Zumbro one being mounted from the chains on the bridge is because sensors need to be accessed at all stages. So that has a really high stage at flood. So being from the bridge, it has the best ability to pull the sensor out and clean it during some of those spring flooding events. And also turbidity specifically, you want to be in the major flow of where you're capturing most representative flow and stream. So that's why we're over in the middle of the channel, except for onto a bank where you're kind of in backwater and not getting a good representative sample of the flow.
Thank you,
for jumping
John.
in there.
Yeah. Another question I have, you mentioned a little bit at the beginning about, using turbidity as a surrogate for TSS. There was a little bit about TP. I think we've thought about using conductivity for chloride because we're metro focused. What else are you guys currently working on implementing with these continuous sensors for other loads or are thinking about in the longer term?
Right now, it's turbidity to TSS and TSS to turbidity. We're kind of looking, we've got our statistics guy, Jimbo, is helping with some of them different regressions and different ways to do it because there's a lot of different factors that are happening in the stream. And it's not a straight linear regression.
And then in some cases, if there's not a strong wastewater treatment plant, impact, we could possibly do a turbidity TP regression. We've kind of thrown that around a little bit. For like the Duluth chloride project, they had continuous specific conductance sensors up there, and they did some conductance chloride regressions that I think they used up in Duluth. So that's about it that we have talked about so far, but who knows?
So we still have some time. Anybody have any last minute questions? And one thing I would request from our speakers is if you're okay with answering some questions from folks, if you could put your name and email in the chat, but it's totally okay if you're not. And so Catherine asked the question, are the sensors deployed year round? That was another question I had. Thank you, Catherine.
No. Well, yes and no. It depends. The ones that we're doing for the load calculations, generally we take them out on October 31st. That is when our program kind of considers the end of the water year, so to speak. I know Jen can speak to it. She has probes out right now in Springs, where she's catching some of the spring or the winter thaws and some of the different dynamics going on down in Karst country. So I don't know. I don't want to speak for Jen, but maybe she can talk a little more about that.
Yeah, so these sensors can be deployed year round. Like Mike said, I have like 5 nitrotaxes currently out right now in Springs in southeast Minnesota, trying to catch some of that snow melt. Even like 2-3 weeks ago, we had pretty good rainfall south of Preston. And that picture that I posted of the nitrotax opened up with the sediment in there, that was actually like a week later. Somehow a lot of sediment and rock actually came out of that spring and covered the sensor. So. But yeah, like Mike said, for the load monitoring sites there, with them being warm water, we get a lot of edge ice. So it's difficult to get to our sensor sometimes. And also with doing calibration checks, our standards would freeze on us. So we tend not to have them out in the winter.
We do have, year-round stations for WPLMN that we're sampling in the winter as well. I think that would continue, but this might be more of our kind of subwatershed open water stations, or we're just monitoring during open water.
Lee Gansky asks, minus lightning strikes, do we have a sense of the lifetime of these sensors?
That's a good question, Lee. I've talked to Hawk about that, and of course they don't give us an exact answer, but like the lamp inside the Nitratax only lasts for so long. So, I mean, we just keep picking them apart at parts, I guess, and have them replaced. But like I had mentioned, that they're actually coming out with a newer sensor. So
Gonna have a follow-on question of that. Are we installing lightning rods now as part of the general setups?
I don't know. That'd be a question for Will from USGS. That was it. I just say, when lightning directly strikes your gauge house, I don't know if there's I don't know if that's gonna help.
Fair.
And I will say too, currently part of there's a bonding bill going through the governor's office right now that's up for legislation this year to expand our network. So we've been trying to secure some long-term funding to get a network off the ground. But so we'll see. You never know once it gets political. Who knows? So then we'll be having some conversations with USGS and DNR, getting something off the ground and permanent stations established.
Good. That's something for us all to look forward to. Gonna fingers crossed about that. I think we're going to wrap up. So I just want to thank our presenters, Mike, Eileen, and Jen. I learned a lot. We have one nitrate tax here at the council, but still figuring out all our uses for that data. So this gave me some new ideas, which has been really helpful. I hope others learned some things as well. So we will be posting this on our website within a week or two. Feel free to send your coworkers there to watch it. And again, sign up for our email address or email list to hear about future events. Our 3 speakers have put their contact information in the chat. Make sure you grab that before you leave. So thank you so much for coming, and have a good afternoon.
Yes. Thanks, everyone.
Thanks for having us.